Okay, rewind that, but... Well, Lorenzo Miniero from Meetecho and Janus, and his talk is about the challenges of hybrid meetings and how they solve them using them, Janus and other tools. Okay. Take it away.
Thank you very much.
I know you're tired, but...
And you're being very brave for being here. Last talk before the dinner, so I know you pretty much hate me right now. So in order to avoid that, I put a nice picture of me as a kid there. So you cannot hate a cute kid like this. Come on. And besides, it shows how, I mean, I've been doing VoIP and WebRTC for way too long. My parents probably should have expected that I was probably heading towards that direction. They didn't know yet. I know now. So. And some of you may know me as the main author of Janus. I got my PhD at the University of Naples, and I co-founded a company called Meetecho. And here's a few links if you want to know a bit more about me, including some links to bad music down there. And just a couple of words before we get started. So I'm one of the founders of a company called Meetecho, which started as an academic spin-off from the University of Naples, where I got my master thesis, PhD, and so on with my colleagues. And we focus a lot on real-time multimedia applications, which is why I'm very much into WebRTC. I was very much into SIP, RTP, all those sort of things, with a strong focus on open source, of course. And among the things that we do as a small company, there's the usual stuff that you would expect, but most importantly, what I'll be talking about today is this. So streaming of live events, and especially what it means in this era specifically. And we are all based in Naples, in the south of Italy, and this is usually where I put a nice picture of the city from above, the Vesuvius in the background, maybe Pulcinella eating some pizza or something like this. But actually, I had to put this picture instead this year, because for the first time after 33 years, so since the Maradona days, we actually won the league for the third time in our history. So, and it's been a very long time, and we've been celebrating for about 1 month and a half so far, and because we won officially at the beginning of May, and we are still celebrating today. And I wish this was an exaggeration, it really isn't. So we really care a lot about this, and so that's why I had to show this picture for once. But coming to what I really wanted to talk about. So as I was saying, this streaming of live events was indeed something that was part of our services even when we started. So mostly for IETF meetings, so you're probably well aware of what the IETF is, so it's where all standard protocols for the internet are standardized. And so we were providing support for them as the official remote participation tool and some ACM conferences, and so it was doing well, so it looked like a growing business. And what it usually entailed meant that we usually flight some people to wherever the conference was, brought some equipment, set it up so that, and I'll show some examples of what we actually did, then possibly update the web pages in order to embed some context-specific functionality. So some events wanted a Twitter feed, some others wanted something like a Slido channel to make it easy to have questions, that sort of thing. Really, the main important thing was that everything was streamed via WebRTC for the benefit of remote participants. And then, of course, I mean, as we all know, something happened in the past couple of years that broke all of this, and this is what I'll be talking about in a minute. But before I do that, let me do a quick overview of how things worked before. So I'll describe a bit how we did things before, and so how we got to a certain point, what we had to change when the pandemic happened, and then where we are now. So how we had to change things once more as soon as meetings became more hybrid instead. And this will be a very short, condensed version of that presentation that you see over there. So if you want to learn a bit more about how it worked before, I did a long VOC talk that's available on YouTube where I cover exactly everything that is covered there. In a nutshell, basically we started about 12, 13 years ago in IETF 80 in Prague just as a very simple experiment. So we went there just with our few laptops. We covered maybe 7-8 presentations, 7-8 sessions that were there, the ones that we wanted to follow, and we started broadcasting those just to see how well it could go. And ironically enough, IETF 80 in Prague was exactly when the RTC Web BOF was started. So it's when WebRTC as we know it today was first proposed to the IETF. So it was kind of a momentous occasion as well, which is also why we started getting, being even more and more interested in WebRTC as a technology starting from that point. And basically, meeting after meeting, we started covering more and more sessions because we started gaining confidence. We started to build better tools for the job. We started adding WebRTC support for Opus, VP8, all those sort of things. up until at a certain point at the IETF 91 in Honolulu, that became our breaking point, not only because Honolulu was the best meeting ever, of course, just because of the location, but also because it was the very first meeting where we covered all 140-ish sessions of the IETF over the course of a week. And it was also the very first meeting where everything was Janus-based. So it was very much an important meeting for us. And from that point forward, we've been covering all sessions of all IETF meetings so far. So it was indeed an important moment for us. And for remote presentations, of course, the same kind of trend was also pretty much visible, mostly because initially we had pretty much almost no remote presentation. The only remote presentation that you can see over there in Taipei was actually mine, because I couldn't fly to Taipei for that meeting, and I had a presentation to make in a BOF, and so we experimented a bit with it so that I could make the presentation there too. Then slowly we started getting some more remote presentations as well from people who couldn't attend, and of course the number was much higher in Honolulu, not only because it was the first time that we were covering all sessions, and so the chances that there were people that needed to present in one of those sessions actually increased, but also because it was harder to get venue for some people. So some people couldn't actually get there, and so you got some more presentations from remote participants needed. But still a very low number if you think about what it means in terms of how many presentations that you would expect remotely in an event today. And the way that it works, which as I'll show later, is not that different from how we do it now. Basically, for audio, you do need to interact with the mixer of some sort. So you see the AVI team over there as a big mixer that's setting up all the microphone inputs and make sure that my voice is played out in a speaker. We needed to do something so that we could hook up, so that everything that was said locally could be sent to the remote system so that remote participants could hear it. And then if anybody from their home wanted to speak, their audio needed to get to the mixer board and play it out loud. And all this without getting any echo in the mix. So basically what we did was simply put a laptop in the room next to the mixer board, set it up so that we could have input and output with an N-1 kind of approach, basically. And then we hooked that laptop to Janus using the Janus zip plugin, because at the time we used Asterisk as the audio backend for our mixed audio in our conferencing system, and so Janus made it easier to basically connect to Asterisk via WebRTC. For video, we used another simpler approach. So we had a static camera that we put, for instance, here, like the one that you see over there. We would, again, feed that camera to a laptop, and that laptop would stream it via plain RTP using FFmpeg to the Janus streaming plugin. And if you're not familiar with the Janus streaming plugin, it's a very simple RTP to WebRTC broadcaster. So you send an RTP stream once, and it becomes a stream that a lot of viewers can watch via WebRTC instead. So it's a very simple way to statically inject video and then broadcast it. And for slides, we did something similar. So we put a splitter in front of the projector, so when people would actually plug their laptop in, they would not go directly to the projector, they would go to our splitter. Our splitter would be seen as a video device from the laptop would do the same thing, send a video stream to Janus of the current screen sharing and send it to the world, basically. That was it. Before, of course, the splitter was connected also to the screen. And of course, if there were any remote presenters, we had a third agent that would basically just act as a hidden participant in the room. So anytime that there was a remote speaker present, that agent would be aware of that, would subscribe to the video stream via WebRTC, and then display it on a second projector in the room. So nothing fancy, as you see, very simple. And this is an example of how, for instance, I did a quick tour for good old Dr. Alex, who is very missed, and Emil from Jitsi. I showed them around a bit at a meeting. I don't remember specifically where it was. I showed them a bit how we do all the setup. And for instance, this shows how we hooked up. You can see the laptop over there that is connected to the mixer board. And the end result, as far as the users were concerned, was really nothing too fancy. So it's really your traditional web conferencing interface. And as a user, you're really not aware of the fact that there are 3 different Janus plugins being used. So we are using SIP for audio, static video for the slides and the main speakers, and then the video room, that's a few plugins for remote participants. As a user, you just see a unified interface where you see some slides, you see some video, you see a chat, everything seems to be working nicely. So you really don't know, for instance, that this and this video are static because they are statically injected, while this video is dynamic because it's an SFU involved. You just see media and content, you're able to interact with it, and this worked pretty nicely, let's say. And in the venue itself, which of course was quite important as well, this is what you'd get. So for instance, that's the feed from the second projector. So the laptop that was getting the video from the remote presenter and displaying it in the room so that they could actually hear and see the remote presenter and interact with him as part of the process. We used a simpler approach for a few other conferences because IETF is very much interactive. So for other conferences, they just wanted to be able to distribute the stream. So they really didn't want any form of remote participation instead. So in that case, it was just a very basic webinar kind of interface. So the setup was similar. So those two videos you see are pretty much done as I showed before. So static mount points sending video to something, but then the layout was much more static instead because we really didn't need much more than that. And it's actually what we used also for our own JanusCon conference. So if you follow JanusCon remotely, this is what it looked like, and this is exactly what we did. We just a Twitter feed in there to show a bit of interaction if there needed to be something. And then, of course, as we all know, a global pandemic hit and changed the whole world because, for instance, this is the mail where the IETF leadership notified everybody that the meeting that was supposed to be in Madrid would be completely virtual instead. And so that was, of course, a big change, and it impacted this very conference as well. So Dan, in his introduction talk yesterday, explained how we had a couple of meetings in person and then a couple of virtual editions instead. So the 2020 was the first ComCon virtual edition there. And of course, this forced us to completely rethink a bit the way that we were doing things, mostly because the platform as we had it at the time worked for something that was very much focused on a local venue and a few remote participants, but was really not conceived for something that should be completely virtual with hundreds, if not thousands of people all remote that wanted to interact with each other. And so basically we re-implemented and reinvented everything to go fully virtual, and I actually talked about this at that very first edition of the virtual ComCon edition. So at ComCon 2020, I explained how we turned that live platform into a completely virtual platform using Janus. And if you're not familiar with it, Janus is a WebRTC server that is completely open source. We conceived it to be general purpose, and you've seen a few examples with the SIP streaming and video room plugin that I mentioned before that are three completely different application logics that you can do for WebRTC. And there's the link to the GitHub repo, to the demos and documentation if you want to play with it, and also to the community, which was quite active. And of course, we wanted to use Janus because, again, we wanted to eat our own dog food, as they usually say. And we also wanted to learn from our own lessons. And again, I had made a presentation a couple of years before at ComCon showing, let's say, a few of the best common practices on how you could scale WebRTC-based applications depending on different requirements. So, for instance, a SIP infrastructure is very different than a broadcasting infrastructure as far as WebRTC is concerned, for instance. And so a few tips here and there on how you could do things. And so we borrowed those tips to actually implement what we wanted to do. And that's a link if you want to learn more. And again, I'll just do a very quick overview of how we moved from a completely virtual platform using that approach. So this will be a synthetic version of that presentation. And basically, we chose to do a couple of different approaches for audio and video. So first of all, the idea was that for audio, before we had everybody connect via the SIP plugin to Asterisk, as we mentioned. So we had Asterisk as a backend. This time, instead, we decided to use Janus as the audio backend as well. So we used the Audio Bridge plugin, which is an audio MCU plugin. So it mixes the audio of all participants and sends audio back. But of course, it made no sense to have every single of that 100 or 1,000 participants connect to the mix directly, because that mixer is going to be overwhelmed with CPU operations if you do that, because you may have to involve too many encoders. It can become problematic quite quickly. So what we decided to do instead is we call it the podcaster approach. So what really matters when you have a conversation, even in a room with 1,000 participants, well, the number of people that are actually going to speak at the same time is limited. So we decided to only connect to the audio bridge the people that need to speak actively at any specific point. Anybody else can just receive the stream using a traditional, let's say, traditional streaming approach instead, which meant that from the audio bridge, we can redirect a real-time mix of the conversation to the streaming plugin, the plugin that we've seen before. And then the streaming plugin can distribute the pre-encoded mix to everybody in the room, which is a much more lightweight and also much easier approach to scale instead. The moment we have to bring somebody else in the conversation, they can just temporarily mute that stream, connect to the audio bridge, and now they are actually actively part of the conversation. So the only thing that you need to be careful about is this switch, let's say, promotion from passive to active listener to active speaker, and then maybe demotion to passive speaker again. And since we are, let's say, delegating the distribution part to the streaming plugin, it also becomes easy to just create some sort of a tree-based topology for that. So the moment you have a lot of people in the room that need to listen to the conversation, you just spawn multiple instances of the same approach, and you make sure that they are all fed with the same real-time mix, which means that you just create a very simple tree-based distribution so that you have a source that is the audio bridge MCU, and then the streaming plugin, which basically weighs nothing because it does nothing more than just fan out what it receives, can actually distribute this to as wide an audience as you need. And for video, the approach was similar but different in the sense that with audio, everything is mixed. With video, we use an SFU approach instead. So every video is sent and received separately by all the participants, which means that we can keep on using the same approach. So using the video room SFU plugin for ingestion and delegating the distribution to the streaming plugin. But of course, this means that every presenter has its own tree-based distribution, which means that you can consider each active video presenter as its own broadcast that is part of the conversation. So an event of sorts can be seen as a collection of several smaller broadcasts that are all sending media to the same audience, basically, if you want. Or maybe some users may not want to see everybody, but just a few of them. That's really a matter of an application logic. And again, it means that it's easy to create a tree-based distribution so that you can fan out that single presenter to as many viewers as you need. And so when you put it all together, you get the ugliest diagram that I ever drawn, which is something that is probably not very understandable. But the idea is that if you have a couple of active participants, they are connected to the audio bridge plugin for their audio part. So they send and receive their audio from there. The audio bridge plugin sends it to all the streaming plugin instances that you see over there, which means that the audiences hear the audio from there. And then for video, you do a similar approach. Of course, the video streams are going to be two separate video streams in that sense. And that seemed to work quite nicely. Of course, it changed a bit the way that we used to work, because typically, as I mentioned, when we did a remote event, the streaming of a live event, it typically meant we flew where the event was and then control everything from there. Of course, when the pandemic was happening, everything was completely virtual, which meant working either from the office or from home in case the event was on a very inconvenient time zone, which it sometimes was. So sometimes we had to work really in the middle of the night and stay up to make sure that everything was up and running. But again, it seemed to work really well, and it's been helping us for considerably. And I mean, the end result is, again, nothing very surprising. So it actually looks pretty much like the same interface that you've seen before. So you see a chat, you see slides, you see video streams, and so on and so forth. The only difference is that now you don't have those static streams that we've seen before. So you don't have something that is coming from a mixer in the room. You don't have stuff that is coming from a static camera or a projector. Everything is contributed by remote participants in the room. And everybody is actually sending and receiving the same things. So, and it actually worked quite well. So we managed to get something that was scalable and could cover events growing very much in size as well. And this is an example of why it changed, of course, because of course, since you had everybody remote, it meant that the conversation could sometimes involve multiple participants at the same time. And so you had, for instance, a panel of 4 people talking to 100 people about, in this case, it was a technological deep dive on DNS, if I recall correctly. And so the pattern of communications changed a bit too. And then, of course, the world started opening again. So, for instance, last year in Vienna was the first time that the IETF decided to go back to meeting in person instead because things started to look a bit brighter. And which meant, of course, that there were some challenges that we needed to overcome because I've explained how basically before the pandemic we had some sort of a static approach, but it also meant that we had a very limited number of remote presentations, just occasional people from the queue and so on and so forth. In the virtual platform, everyone was peers basically, so everybody had the same sort of functionality and the same, they were basically the same level of participants. After the pandemic, we ended up in some sort of a hybrid meeting approach instead, which meant at the very least we could expect some sort of an even distribution. So maybe half people would be local, half people would be remote, maybe 60-40, that sort of things. But it still meant a very different distribution from the one that we'd had before, which meant that we also needed to worry about how to get them, those two different, very different groups to actually interact with each other effectively. And about the infrastructure, the easy thing was that we could basically focus on very much the same virtual one, mostly because it was built to be scalable, and so it made sense to keep on using that. But it also allowed us to start treating also the previously static feeds as dynamic feeds instead, because we could basically just inject them as virtual participants and have them distributed as in that tree-based distribution that I introduced before much more effectively. And I'll explain a bit how the interaction in the venue changed as well. And of course, there were also things that we needed to change in how we presented and consumed stuff in the venue itself, so how we would present everything. And so for audio, I explained how before we had a laptop connected to the asterisk via the SIP plugin. Basically, this approach didn't change much, with the difference that now we have a dedicated audio box that is based on a Raspberry Pi that uses high-quality XLR cables to connect to the mixer for better quality. And then we use the Audio Bridge plugin for the audio instead. So functionally, it's the same. The pieces change quite a lot, though. For video, as I mentioned before, we were doing something that was quite static, and so it would be harder to scale and distribute the way that we changed things. And so we decided to do something like this instead. So rather than have a single camera, maybe have at least a couple of cameras in each room, so that one would always capture, for instance, me, the speaker, and the other camera would always capture you, the audience. And each camera would be associated with a Raspberry Pi that would create a WebRTC peer connection to the video room plugin, and then that video would be distributed automatically, as we've seen in the previous slides. And this is an example, for instance, of how we set up a couple of cameras when we need to set up a room. And I mentioned at least a couple of cameras because there are some sessions, like the plenary, which always happens in a very big room, where we can set up even up to 5 or 6 cameras, and then we orchestrate which one we want to show at any given time. And this is, let's say, how it ended up visually. So in this case, people joining remotely would see a couple of streams from the room and a couple of streams maybe remotely. And in this case, they would all be injected in the platform the same way, rather than statically versus dynamically as before. And as you may notice, I didn't mention the splitter feed from the projector, and that's because this time we decided to actually get rid of it. So right now, all people that are going to present an event, for instance, at the IETF, they don't actually share their screen directly by plugging via HDMI, but they actually publish things via Meetecho, for instance, via WebRTC, and then we consume the content via WebRTC and we display it that way. And of course, not all content is shared via WebRTC. We actually support, for instance, the concept of preloaded slides. So you upload a PDF, we turn it into a series of images, and then we just send the triggers about what slide is being displayed at any given time, which is a much more lightweight way of doing things. And that's actually the overwhelming majority of presentations. But you can also share your screen via WebRTC that way. And this actually made it much easier for us, because it meant that no matter where the source was coming from, so if it was a remote presenter from home or a local presenter from inside the venue, we would treat their streams exactly the same way. So in both cases, it would be either a preloaded slides or a WebRTC stream, and we could distribute it via Meetecho the same way and consume it also in the venue the same way. And which meant that, of course, something changed also in how we display the content, because before we just had to worry about how to display a remote participant. In this case, we had to also display the main content itself. So, for instance, my presentation right now in Meetecho would be uploaded via via Meetecho and then consumed by an agent like a Raspberry Pi somewhere connected to this screen, and that agent would be presenting stuff on that first screen. And the second screen would do pretty much the same as before, so receive remote participants, display them, but possibly also add additional information like the virtual queue who is speaking in the specific time, transcriptions that I'll show in a minute, and so on and so forth. And this is an example of how it looks in one of the rooms. So you have two different screens. One screen is actually showing a shared screen, so you can see that's a PDF viewer that Warren over there, the guy with the cowboy hat, was sharing. And then the second screen was showing a remote participant, and on the side you see those colored bars, they are actually the remote queue in action. So it actually shows people that are actually in the venue or remotely that are queued up for making questions, basically. And the queue was actually an important aspect because, as I mentioned, we have a lot of people that are participating locally, a lot of people that are participating from home, and we need to get them to interact with each other. And historically, the IETF has always relied on the concept of mic lines for queues. So pretty much what Luca is doing right now, asking who needs to make a question and so on. In the IETF, it works where you have a microphone standing in the middle of the room, and who wants to make a question goes behind the microphone, and you get a physical queue happening, which of course doesn't work as nicely when you have remote people involved, because remote people cannot physically appear behind that microphone. And in a fully virtual platform, of course, it was not an issue because everybody was in the same queue. And so we had the problem of how we could actually get both local and remote participants appear in the same queue so that they could be treated fairly in terms of how they wanted to speak. And basically, we managed to solve that by using some sort of a very simple companion web app, because the remote participants have their own interface for getting in queue, and we've seen it briefly before. For local participants, we needed something to allow them to get in the same queue as well. And so, very simply, we created a very basic web app where you could just open your phone, open a web page, and then press a button, and you would appear in the queue out there. So basically, it looks like this. So remote speakers have a view of the queue. They can get in queue by raising their hands and so on. Local participants can just open a web page, for instance, using a QR code that is visually displayed in the room, or using one of the links on the agenda, and they end up with an application web page like this, where they can just get in queue, and then they appear something like this. So the green slots are for people that are currently speaking, whether they are local or remote. The yellow lines are for people that are actually in the queue. And you can see from the icon that we can distinguish who is actually in the queue from their home and who is in the queue from the venue itself, which helps the chair decide, for instance, how to progress with the questions and so on and so forth. And we decided to also expand a bit this tool to also do a few other things, mostly because it uses the same backend as the main application, so it uses the same credentials and these sort of things, but of course with a much limited set of features. We didn't want to weigh it too much. And so, for instance, you can use it to get in line to talk, but also as a remote clicker, for instance, because I mentioned that for slides, we support that preloaded slides approach. So you upload a PDF, it gets translated to a series of images, which means that if you want to advance the slides, you just need to send a message to the server to say, now go to slide 4, slide 5, slide 6. And that's simple to implement in a web page because it could be as simple as a HTTP post somewhere, let's say. So it's a very simple way to have an integrated clicker that works with everything else. And it's also useful to participate to the so-called polls. So whenever there is a, let's say, quote-unquote votation, because they don't really vote in the IETF, but whenever you need to get feedback from people in a room in the IETF, they historically hummed. Basically, everybody would start humming as loud as possible to see if there was agreement on something in the room, and then you got some feedback, basically. In this case, since you have people that are on site and people that are remote, you need a simpler way to aggregate anonymous feedback, which is what we implemented here. And this is an example of how this polling works. So whenever there is a question that needs being made, the chair can present the question, do you agree with this, do you not agree with this? You can decide to raise or not raise your hand, and you can do it either that way or via the simple web app that we've seen before. We added support for live transcriptions as well in using DeepGram in this case. we started this for the Yokohama event, and it was actually quite useful because it allowed us to display a live transcription of whatever was being discussed in the room, both in the Meetecho interface and also in the second screen in the room, which was basically very much a support for people that maybe needed some help from a visual help of whatever was being said in the room. And it actually turned out that it was actually quite useful because we got some feedback, for instance, from Twitter that since it was a meeting based in Yokohama, so there was a high participation of people from Asia in general, and so they benefited a lot from having some sort of visual support to possibly some audio that could be harder to understand by native speakers. And I'm getting close to the conclusion. I've showed so far how we basically set up everything in order to stream stuff, display stuff in the room, and so on. But of course, all this needs to be controlled somehow, because if we have so many devices spread across 8 different rooms at the same time, because that's how many sessions run in parallel at the IETF, it means that we cannot physically be in all of those rooms. So we need to be someplace where we can control everything and what is happening. And for instance, we made sure that each of those devices, so all those Raspberry Pis that I mentioned, for instance, has some sort of an agent that can register to a controller, and this controller can send it commands. So for instance, to start or stop capturing audio, or to change the gains dynamically if audio is too loud or not loud enough, or maybe stop cameras or do some pan, tilt remotely, these sort of things, or even just decide what we want to display on the different screens. So we wanted to make sure that all these things could be done remotely from a control location, because otherwise it would be a nightmare, especially in a very large venue as the IETF usually has. And for instance, this is the interface that we created to monitor all sessions at the same time. In this case, you can see 6 different sessions. In practice, it's usually 8 up to 9. So, and for each of the sessions, you can see all the cameras that are active. When you hover over one of the webcams, you can move them around, you can tilt them so that you can follow the speaker if they move. You can decide what to start, stop at any given time, so it's much more convenient for us. And since we are gamers as well, so we decided to tinker a bit also and make it fun as well as part of the process. So we don't always use this, but when we do, it's fun enough to basically move the webcam around as if we were playing a video game, which is always fun. And we also, since, as I mentioned, we are also responsible for all the screens in the room, so the main screen displaying slides and the other screen displaying other content like remote speakers, queue, and transcriptions, basically those agents just display a web page. That's as simple as it is, basically, which means that we can open those same web pages in a grid and monitor everything that is being displayed in every room at the same time, which means that we can, for instance, see that not all slides need to be boring. Some can be actually very nice. We can see, for instance, when a new presentation is being shared, or maybe that there is a new poll that is about to be started, so what's the current status of the poll? I mean, so on and so forth. We can see a lot of things just from a bird's eye, which is very helpful, because anytime that there is an issue, maybe something that is not being rendered, we know where we need to put our hands in order to see if something's broken. And we do, of course, the same for chats, which are based on Zulip now, so it's easier to control them from a web page. And just to conclude, I spoke a lot about NDI in a few other presentations. So for instance, I talked about it in a couple of blog posts. I talked about it in a virtual ComCon a couple of years ago. I talked about it at ClueCon and so on. And it was actually used in practice at ComCon Virtual 2021, because the Janus NDI plugin was part of the very early broadcaster VC stack as basically a proof of concept kind of approach. So it actually can be used, and in fact it could be very useful for patching streams in and out of the venue if you don't want to, strictly speaking, make use of WebRTC, because it could be very useful, for instance, to an AVI team as one there's in the back. But in practice, we are currently not using it in any of our workflows yet, mostly because we haven't had the need yet, but it is something that we could do if we wanted to. And basically, to conclude, and I hope that I'm not astonishingly late, so we started a complete refactoring of the web UI, which is almost finished. I didn't bring a screenshot, but hopefully it will be ready for the next IETF meeting, which is in San Francisco next month. We completely redesigned the user interface to make it more mobile ready, and also we wanted to make to make it more easily be extensible in case we needed to add more features, because the interface that exists now was updated over time, anytime we added new things, which meant that it was starting to become a bit more problematic to update for the job. So we wanted something that was modular at the very outset. We want to make some improvements on transcriptions, because I mentioned how they helped, especially some non-native speakers, these meetings, but we also noticed that it really does some work, because, for instance, it completely lacks the context. For instance, in the case of IETF meetings, there's a very heavy usage of acronyms and specific IETF terminology that, of course, the deep ground models know nothing about. So it does need some tailoring. We could experiment with other backends as well. So Banafo comes to mind, or Google Speech, or Whisper AI, or whatever. So it's something that we really want to improve and expand on in the future. But most importantly, of course, we want to expand the events base as well, because right now we have bespoke solutions for IETF, which I've talked extensively about today, but also RIPE meetings, which are usually sometimes as large as IETF meetings that share the same level of requirements in terms of remote participations. So the idea is to try and replicate the same approach for other events too, taking advantage of the modular approach that we'll benefit from in the future. And that's basically it. So I hope I didn't run out of time and that I didn't speak too fast that you didn't get anything that I said. And these are just a few links if you want to get in touch with me, and I'm happy to take any questions if you have any. Thanks.
Thank you very much. Tori.
A while back, you were talking about scaling Meetecho platform. I was wondering, have you developed any tools or know of any good tools for load testing WebRTC platforms aside from IETF?
Yeah, no, we created our own tool that I actually presented at Kamailio World a few years ago that is called the ad-hoc. So it's basically, the idea came from, let's create a tool that can create a lot of peer connections and attack Janus. So it's Janus attack, JATAC. That was basically the idea. And so it's a command line tool that you use to programmatically create a lot of peer connections depending on some characteristics that you want. So if you want to create a lot of ingestion streams, you can do that. If you want to create a lot of subscribers, you can do it. If you want to inject RTP traffic in those connections, you can do it as well. And so basically it's a bespoke tool that we created for ourselves. So it's not open source, but it has a WebSocket interface that allows us to create very simple controllers that can basically dynamically spawn as many peer connections as we need and connect to Janus and send a lot of peer connections. So we use it on a regular basis to check whether or not, for instance, the scalability part that I described actually worked or not. And so it was a very helpful tool for us.
Thank you. Any other questions? Oh, so.
Impressive stuff, Lorenzo. I have a question about screen sharing. So in the first model, you guys were taking the screen with a splitter, so directly from the source. And that probably means that you were also treating it as a webcam of sorts, so it's like 30 FPS and all the good stuff. But now that you're taking it directly from the user, it goes through the browser's interpretation of how screen shares should work like. So when they're not using the pre-uploaded screen shares, have you noticed, like, are you happy with the new way, or do you think you get, like, a bit more consistent quality with the previous one because you got it from the source? What's your experience on this one?
I mean, the only actual difference that you may notice is for people in the room, actually, because remote people were still receiving the remote participants would see the WebRTC feed even before, because that's what they were getting. And so right now and before, remote speakers get really the same thing. So the only change is for local attendees, because what they see on the main screen here is not something that actually physically comes from my laptop and then goes via HDMI on the projector over here, but is actually being streamed via WebRTC to the server and then consumed as a WebRTC stream and displayed in the room. So any problem there is actually going to be reflected to the people in the room, because they see a stream that is actually processed and compressed by the fact that it is a WebRTC stream. But actually, we didn't notice any particular issue, mostly because there are tricks by which you can make WebRTC screen sharing a bit better in terms of quality. But Even without using those, the content is pretty much static most of the time. So slides are usually not very dynamic, even though we have also used it for sharing videos, for instance, these sort of things. So we didn't notice any particular degradation of the quality in the venue itself, which meant that at least for us, it seemed to pay off. So of course, it's a bit more tricky for the remote presenters themselves, which may be used to just plug their HDMI, open their PDF viewer, and be done with it. So it's sometimes a bit more of a learning process for who needs to present locally to remember that they have to do it this way or that way. But we try to make it as easy as possible by, for instance, automatically preloading the presentations of every session by pulling the information from the IETF data tracker. So before a session starts, we pre-upload them all. So all they need to do is find their presentation in a list, click it, and it appears. So we try to make it as easy as possible in that sense. But when MobileTC is used, it seems to be working fine as well.
Thank you.
Oh, not a question.
So in the tree-based architecture, where you showed the streamer distributing it, streamer plugin, what about feedback? What about PLIs, negative acknowledgement? They must all flow back to the source.
Yeah, so it's pretty much, this diagram here shows it in practice. So, oh, sorry, can you display the content on the screen? Yeah. So in this case, you have, for instance, the video room plugin feeding two different instances of the streaming plugin. So these two are acting as distributors. And we actually made it so that there is no complete RTCP stack between them. So they don't really exchange any formal statistics about the quality of the distribution and so on and so forth. But what they do create is a way for those streaming plugin instances to ping back a PLI request if one of those viewers requests it. Because of course, if a new participant joins and they need a keyframe because they may be joining in the middle of things, they will actually see the streaming plugin as their own interface for video. So they will send the PLI to that Janus instance, and that Janus instance somehow needs to relay it to that other Janus instance so that it can be relayed back to the actual video source. And we actually created an RTCP feedback mechanism just for keyframes between those two instances so that that feedback can bubble up until it needs to go. With, of course, some throttling in place because you don't want 1,000 keyframe requests all going to flood that poor presenter over there. So there is some throttling in place.
Thank you. Anybody else? Oh, good.
Nobody's hungry, apparently.
Lots of success.
A couple of things about the application. Did you find anything that you need to do more in terms of collaboration with the application? Because you probably need people to collaborate on, see documents or design together and stuff like that. And the other aspect is about recording. What did you do for recording?
Yeah, so I'll start from recording because that's the easier thing to answer. So in Janus, recording is fairly straightforward because Janus basically just records the individual streams. So any stream that we receive, we save a structured dump of the RTP packets. And in the case, for instance, of audio is already mixed. So actually, no, I'm being incorrect here. So we save the separate audio streams of the active participants because the mix may be incorrect. And so we have all the individual contributions, and then we pass them to a post-processor later on to mix them all so that we can create, for instance, an asset that you can push on YouTube. And which is exactly what we do. So if you go to the IETF channel, you'll see that there are the recordings of all you want the recording to look like. And so if you feed it all the individual recordings that you have, you want the recording to look like. And so if you feed it all the individual recordings that you had, then you can dynamically create different layouts, which is what we did. And sorry, the first question was related to the features. Yeah, so we actually, if all those buttons that you see over there and a few other buttons that you see over there, they are all actually individual features that we added over time. So, for instance, the show of hands was a feature that we had. There's a shared note editing tool that is actually provided by, I don't remember the name of the tool, but it's an open source application that the IETF uses that we can embed in our own application. So for strictly speaking related stuff, so let's say drawing stuff on the screen, that's something that is not there, mostly because it's never been a requirement of the meetings that we supported. But in principle, especially with the new user interface that we are building it so that it can be modular and you can add multiple, even new stuff that doesn't exist before and have it fit into one of the columns that will be available as part of the interface.
Thank you. Good. So, anybody, any other questions? Good. So, thank you, Lorenzo.
Thank you very
for a
much.
Great talk.
Have a nice dinner. Thank you.
And, well, this was the last talk for the day. See you back at 6. I think it's the room over there. So the big room for video games and then dinner. Or dinner and then video games, whatever you prefer.
One of the two.